Hello students, and I would like to say welcome back to all of you for this Misostudy video class. As you know that we are in a phase to discuss some problems from wave optics, a very important chapter, fine. And some time back we uploaded a video for this wave optics JEE Main pattern exercise. There were 5 questions onto that. So in the same sequence, this is new episode, fine. So question numbers may be changed from like 1 to 5 we discussed in episode number 1. So in this it's like 6 to 10, and in coming videos episodes it's maybe like 11 to 15 and so on, fine. So once again we are here to discuss some important and interesting problems from this topic, that is wave optics. Till now, if you have revised those 5 problems that we discussed in previous you can say video, so over here after watching this video, I think, or it's my assumption, that you may find yourself in a much better position, fine. So with this positive note, let's start this discussion about this wave optics JEE Main pattern exercise number 2, you can say. Yes, the question is in continuation with that previous you can say presentation. So in this there is a question which is obviously based upon the phenomena of polarization and application of a device that is known as Polaroids, fine. What is the problem? An unpolarized beam of light is incident on a set of 4 polarizing plates, okay, such that each plate makes an angle pi by 3 with preceding sheet, okay. The light transmitted through the combination finally is how much? Now, first, if you try to recall, in previous video we started our discussion with the same type of problem, and there were 2 plates, 2 tourmaline crystals, crystal number 1, crystal number 2, C1, C2. In this I make the number 4 times. It may be tourmaline crystal, it may be like that, but there are 4 plates. 4 plates means, let me show you in this fashion. Let us say these are 4 plates, fine, 1 to 1 they are arranged, 1 then 1 then 1, but each plate making angle pi by 3 with the previous one. It means if you just analyze using these 2 plates, then if this is first one, okay, then second is twisted like this, third again twisted with the second as pi by 3, pi by 3 means 60 degree. So you can say the third and first angle is not pi by 3, that is different angle, and fourth is with third making angle pi by 3, fine, very clearly mentioned with the preceding sheet. So second at pi by 3 with first, third at pi by 3 with second, fourth at pi by 3 with third. So keep this simple aspect in your mind, fine. Now with this we are starting our discussion over here. Obviously the basic formula that we are going to utilize in this particular problem is I is equal to I naught cos square theta. This is the basic result we are supposed to use, but obviously there is not one polarizing sheet, there are 4. So we have to use this formula in combination, but with some sort of careful approach, okay. Basic result is this one, and from one by one I will explain, okay. From first plate, when unpolarized light will pass from the first plate, what will happen? So from first plate, I1 is equal to, I1 is the intensity that is coming out from the first plate, and assume I0 as the intensity of the original light, fine. So I1 is equal to I0 by 2, using Murler's law, simple. This is the situation with the first plate. Fine. Then for second plate, now this I1 light after coming out from first plate will strike to the second plate and then comes out. So basically I naught is original intensity, I1 is the intensity that is coming out from first plate, and similarly I2 is the intensity that is coming out from the second plate. Okay, so I2 is equal to I1 cos square theta. Fine. Now what is the value of theta? Pi by 3. Pi by 3 means 60 degree and cos 60 is 1 by 2. So square of 1 by 2 is 1 by 4. Fine. I think I should write down all these steps. Okay. What I will do? I will use the value of I1 from here. Fine. So first if I am writing like this, then I can say 1 by 4. Okay. I2 is equal to I1 into 1 by 4. Why? Because theta is equal to pi by 3 as pi by 3. Fine. At any point of time you can use this value of I1 as I naught by 2, but for the time being we are not using that. So what we can say, I2 is equal to I1 by 4. Fine. So if it is equation number 1, it is equation number 2. Similarly, we have to apply it for I3. I3 means, now let me allow to do one thing. I would like to mention I1 is equal to I naught by 2 equation number 1. Then I will say I2 is equal to I1 by 4 equation number 2. Fine. Let us save it here and clean out this entire portion. Then go for third plate, that is I3. I3 means first plate, second plate, third plate. So I3 is equal to I2 because the waves coming out from this second plate ultimately reaching to this third plate. So I3 is equal to I2 cos square pi by 3. Let us put the value as such. Now it is again going to be how much? 1 by 4. So you can say I3 is equal to I2 by 4. Equation number 3. Fine. Equation number 3. Now here you can do one thing. Use the value of I2 over here. So I3 will be I1 by 16. I hope you all are going to be comfortable. That is equation number 3. What I did? I simply replaced the value of I2 from here in this equation. Simple replacement of the values. So now I can mention one more thing over here, that is I3 is equal to I1 by 16. Equation number 3. Fine. Now what about I4 in similar fashion? Fine. So let us try to find out the value of I4. That is I4 is equal to, it is not iPhone, I4. Okay. I4 is equal to I3 cos square pi by 3. That is I3 cos square pi by 3. Fine. So what you will get? You will get it as I4 is equal to I3 by 4. Fine. but I3 is equal to I1 by 16. So, what you will get? You will get is I4 is equal to I1 by 16 multiplied by 4, that is 64. So, I4 is equal to I1 by 64. Ultimately, we have to find the final intensity. Fine. The light transmitted through the combination is, what is the final intensity? So, what we are supposed to do now? Put the value of I1 from this equation number 1 in this relation. Fine. So, finally, I4 is equal to I1 by 64. I1 is I naught by 2, that is I naught into what? 1 by 2 into 1 by 64. Fine. So, it is going to be how much? 64 into 2, that is 128. So, finally, you can say the correct answer is A, that is 1 by 128. Either you can use 1 or you can say I naught value as per the requirement of the problem. Ultimately, I can solve this question in just one step, but the problem is many of you may get confused what exactly the teacher is doing. So, that is why I explained this particular question to you in this fashion. Now, one more thing over here. Let us say every next plate is not you can say oriented at pi by 3. Let us say first is pi by 3, then pi by 6, then pi by 2, something like that. So, that is why I explained step by step that if all the angles are not same, systematically you can apply this formula. Now, students, on the basis of my own experience, I would like to share a fact. These simple questions, if you are not attempting with cool mind properly, you are bound to get incorrect answers. Fine. So, these are very simple questions. Do not rush. Give at least 50 to 40 seconds time and get the correct answers. Fine. So, this was question number 6 of this particular combination of second set of questions from the wave optics of class 12th or your competitive exams. Now, I would like to move for the next question, fine, of this particular combination. Here is your next question. White light reflected at normal incidence from a soap film. First thing, white light. White is important. Important is white light means combination of various wavelengths. Fine. So, moment you are reading these type of problems, you should take care of these statements that what is the meaning of white light. White light means combination of various wavelengths. Now, it is reflecting from a soap film. So, obviously, this question is associated with the interference pattern. Fine. So, has a minimum at 6750 angstrom. In general, 4000 to 7000 angstrom is your wavelength for the white light, fine, visible light basically, and maximum at 7500 angstrom in visible region, roughly 4000 to 7000 angstrom, with no minimum in between, fine. If mu is 5 by 3 for the soap film, refractive index of the soap film, what is the thickness of this soap film? So, the question is, find thickness of, do not worry, I will move out, find thickness of soap film for this interference. Okay. So, how much. Now this question, if you are not in a position to recall the formula, really you will not able to solve it. Even in my previous video of these type of PPTs of discussion of problems, I mentioned specifically that in this particular chapter there are two main aspects. One is interference, another is diffraction, and there are just 4 formulae for maxima, minima, maxima, minima. Fine. So at least you should try to retain these formulae by writing, do some practice. Okay, let me allow to mention the formula over here. Twice mu t is equal to n lambda 1. Why I used yellow color over here? Because this n order is important. Fine. Now let's say this is equation number 1 and it is representing what? It is representing minima. Fine. Now similarly, twice, again I will use yellow color, but for a specific reason, please wait for that. Twice mu t is equal to 2n minus 1 lambda 2 by 2. Equation number 2, it is for maxima. Fine. So first thing, students, my request to all of you, practice these simple formulae. That is utmost important. First thing, because if you are not comfortable with these formulae, and something which I mentioned with yellow color is really important. Now in equation number 1 and 2, what you can say about left hand part? Equal. Fine. So what we can write down? We can write down from equation 1 and 2. Fine. From equation 1 and 2, we can write down 2n minus 1 into lambda 2 by 2 is equal to n lambda 1. Simple. So let me allow to write down that. That is 2n minus 1 lambda 2 by 2 is equal to n lambda 1. Fine, because left hand side of both these equations are equal. From here after solving, because the value of lambda 1 lambda 2 is visibly given. Fine. So after solving, what we will get? N is equal to 5. Fine. After solving, that I am not doing that much trivial calculation. After solving, n is equal to 5. So now at least you can say, if n is equal to 5, then we can calculate these values even from equation 1 or 2 as per your wish, no problem. Fine, because mu is given and you have to find the value of t. Okay, so let's allow me to erase this portion, and I want to use this formula over here just below the question. Now from here what we can say, from equation 1, let us say from equation 1, question is in front of your eyes and final solution is also in front of your eyes. So twice mu t is equal to n lambda 1. Value of n is 5, lambda 1 is that is 6750. Yes. So t is equal to 5 into 6750 angstrom upon twice into 5 by 3. Fine. Now once you solve it, you will get A as the correct option. Simple calculation is now remaining. You can use this formula number 2 also or 1 also. Ultimately, by solving these results, we tried to find out the value of n. That is why I mentioned this term with yellow color, different yellow color, because it is our target. Fine. These questions are not difficult, but the way I explained, I emphasized repeatedly, I told you, you have to take care of what? That you are comfortable with the formulae used in this particular discussion. Fine. If you are comfortable with the formulae, really you are going to be rock. Things are difficult only for those students who are unable to retain the formulae. Fine. Because in examination hall, obviously you can't drive these results. So here comes your next question. In a two-slit experiment with monochromatic light, somehow we are moving towards interference pattern discussion. In a two-slit experiment with monochromatic light, fringes are obtained on a screen placed at some distance from the slits. Fine, I will show you the diagram, do not worry. If a screen is moved by 5 into 10 to the power minus 2 meter towards the slits, fine, then change in the fringe width is this much, fine. If the distance between slits is this much, then wavelength of the light used is what exactly? So first I would like to show you the diagram. The diagram is, this is S, first source, then source number, I think I should create the diagram close to this question itself. This is first slit, then this is S1 and this is S2, fine. And after that, screen is placed like this, okay, and this gapping is capital D. This is screen. You are getting the pattern. What the pattern is, I am not going into that detail. After some time, what happened? You shifted the screen towards the slits, means now basically the screen is placed at this yellow segment, fine. Initial, this was position number 1 for the screen and this is final or second position of the screen. Obviously, this distance is reduced to 1, let us say D prime. You can say D prime, D, lambda, everything is given in this particular problem. Fine, they are interested to find the change in the width of the fringes. So, what is the formula for the fringe width? Fringe width beta is equal to d lambda upon twice d. The formula is beta is equal to d lambda upon twice d, where twice d is, you know what? Twice d is this spacing, okay, 2d. This is this much spacing. Now, ultimately, if we are changing capital D, so something will happen. So, there are two approaches for this particular question. What are? Either calculate fringe widths separately, then subtract, or in one go you can calculate. So, let me allow to do that. Fine, it is your choice. Whatever method you like, you can follow that. Beta 1 minus beta 2 is, actually you have to find the wavelength. Yes, no problem, you have to find the wavelength, good. So, beta 1 minus beta 2 is equal to 3 into 10 to the power minus 5 meter, fine. This is the fringe width difference because of this change, fine. beta 1 is equal to lambda d1 upon d or 2d, because here I mentioned 2d, so I can use 2d or d. That is simply the spacing between two slits. Fine. So beta 1 is equal to lambda d1 upon d and beta 2 is equal to lambda d2 upon d. Fine, simple results. But you know the difference in the values. Fine. So if we use this result, so what I can write down? I can write down beta 1 minus beta 2, beta 1 minus beta 2 is equal to, take out this lambda by d common, d1 minus d2. That is beta 1 minus beta 2 is equal to lambda by d, d1 minus d2. This beta 1 minus beta 2 value you have, lambda you have to find out, slit width this small d or 2d is given in the problem, d1 minus d2 is also given in the problem. What I will do, I will erase out this portion and then I will mention further steps required for the understanding over here. It is anyway not now a difficult aspect, it is a very simple approach now, but let me allow to mention it. Fine. Few of you may feel some sort of difficulty, so that is why I would like to mention it. Lambda is equal to beta 1 minus beta 2, simply arrangement of the terms, nothing else. Fine. Upon lambda is equal to beta 1 minus beta 2 d1 minus d1 minus d2 into d or 2d. Every value is given, put the value, you can get lambda is equal to, fine. So as such, this question is not difficult one. First you have to visualize the problem and you can say it is a combination of two very simple problems from interference pattern. Fine. Now we would like to move definitely for the new questions in this category. It may be like that few of you may feel I am moving bit slower, but yes, it is required. It is something which on the basis of the feedback we are getting, like we should explain each and every step, it is required. So that is why I am emphasizing. If you are in a phase of like that fast learning, you can skip out these few basic details, but in general students love to get the every step by step solution. Fine. Here it is, 9th question. Interference fringes are produced by a double slit arrangement and a plate or parallel plane glass of mu is equal to 1.5 is interposed in one of the interfering beams. Actually what is happening on, I am going to explain you with the help of a diagram, but just wait for some time. If the fringes are displaced through 15 fringe widths, then thickness of glass plate is how much? Actually the problem is, let me show you once again. This is first source, fine. After that these are S1 and S2, two slits. Now this is screen, fine. This is screen. What will happen? Let us say you are getting fringes at this place or at this place, anywhere like this, fine. Now if I introduce a glass plate of some thickness and some refractive index, so obviously some optical path difference will come into picture. So the discussion is associated with that optical path difference, fine. I hope the diagram, which is a very simple diagram, is clear to all of you. Now what the formula and what exactly the solution of this problem, that I am going to explain you step by step. Okay. And because I explained the problem to you, so for the time being, if some part of the questions are not visible to you, please don't mind it, because entire question is clear to you and I am going to provide you the solution. Fine. Extra optical path difference due to extra optical path difference due to glass plate. Extra optical path difference due to glass plate is delta x is equal to mu minus 1 into t. Simple formula. Fine. Now, as 15 fringes are displaced, because 15 fringes are displaced, so you can say delta x is equal to 15 lambda, basic replacement of the values. So, from here what you can say, mu minus 1 into t is equal to 15 lambda. Okay. So, what I will do, I will replace this value here itself. Fine. 15 lambda. Initially I thought to do it, but I think it is better to explain it than it only to do it. Now, 15 lambda is equal to this much. Fine. Mu is given to you, t you have find out, and lambda is also given. Okay. Lambda given, mu given. So, finding t is nothing but a one step calculation, that is 1.8 into 10 to the power minus 3 centimeter. So, 1.8 into 10 to the power minus 3 centimeter, very simple question. Fine. Directly formula based problem. Now, let us move for the next problem. Okay. A beam of light of wavelength lambda, for the time being just read the problem like this, from a distant source falls on a single slit 1 mm wide and the resulting diffraction pattern is observed on a screen some distance away. The distance between the first dark fringe on either side of central maxima is. Directly diffraction concept based formula oriented problem. Fine. So, rather than going into any type of details or explanations, I think mentioning formula and putting the values is more than enough. But if you do not have the practice of the formula of this concept, obviously you are going to face some sort of difficulty. So, please do the practice. Angular separation between first dark, some crucial point I am mentioning with different colors. Fine. So, angular separation between first dark fringe on either side. It is mentioned on either side, that is of the maxima, on either side of maxima. Fine. It is 2 theta is equal to 2 lambda upon A. Basically, this formula I used in the previous video also. So, you can say it is a repetition of that concept just to emphasize that important aspect is formula remembering. Fine. So, 2 theta is equal to 2 lambda upon A, and linear separation then going to be how much? So, linear separation at any distance capital D is 2 lambda upon A into D. Fine. So, this is also the linear separation. Fine. Now simply put the values and 2.4 mm is the answer. 2.4 mm is the answer. So this way students, again we completed a discussion of few good problems based upon this wave optics. Only required from your side is revision and practice. Fine. So with this hope that you will revise and obviously will try to learn some formulas and concepts. Very soon we will back with more good questions for your refreshment. So till then, take care of yourself, keep revising, have a nice time.